Okay, so we'll jump into our first topic of voting, mathematics of voting. So the act of voting, heading into a voting booth and checking off your personal choice, okay, is only half of how we decide, we make decisions as a society, okay? The democratic process is really revealed in how we take all those collective opinions, all those individual opinions, and come up with one collective decision. Okay, so that is a mathematical process, how we do that. So how do we sift through the many voices of a society to find a collective voice? How well do we do it? Is the process fair? And studying the answers to those questions is the basis of voting theory, which is a branch of mathematics, and it's what we're going to study this chapter. So it may seem obvious and straightforward at first. So it may seem straightforward because we have grown up so ingrained in the system where this is how we make decisions, we vote, right? But just to say just count the ballots and use that count to determine the winner in a consistent and fair manner is actually a really complicated thing to do. And surprisingly, it turns out that if you have an election with 3 or more choices, there is no consistently fair democratic method for choosing a winner. So it seems kind of unbelievable to say that there is no fair way to do it, because that's what we base our society on, is that we try to make decisions in a fair way. But it actually is the case, and we are going to study this counterintuitive result by examining several different methods of voting and seeing how each one fails in some really important way. So, first thing we're going to do. If I was going to show a movie in class, what movie might you nominate? Somebody give me a movie that you'd like to see. Crash? A Beautiful Mind? What? Pulp Fiction. Oh, we have good choices in this class. B-E-A-U. Pulp Fiction. Okay, so now I'm going to have each of you write down your first, second, and third choice. Just quickly jot down what's your first, second, and third choice of these 3. So let's see, I think mine would be all right, everybody have their choices written down? Okay, so what you just wrote down here, by writing down all 3 preferences, first, second, and third, we call that a preference ballot, which is a little bit different than putting down just your first choice. So we put down all, where you rank your choices, called a preference ballot. Oops. So a couple of notes regarding preference ballots. A voter's preferences are transitive. Anybody know what the word transitive means, or heard it in a previous class somewhere? First, what? Oh, verbs, yeah. Oh, yeah, no, I don't think it's really related to that. That's a good guess. That's a good guess. Anybody heard it in a math class? The transitive property of equality? Sort of, yeah. So transitive, or transitivity, okay. Here's one example. If A equals B and B equals C, then what can we conclude? A equals C. If A equals B and B equals C, then A and C have to be the same. They have to be equal. This is called the transitive property of equality. Okay. So equality is transitive. What else is transitive? Anything? What's another example of transitivity besides equality? If something is, it's hard to say it with fill in the blanks because I could do greater than, right? If A is bigger than B and B is bigger than C, then what? A has to be bigger than C. I could do sort of a less mathematical example. I could say if Caitlin is shorter than, what's your name? Amber. And Amber is shorter than, who's taller than Amber? You're probably taller. What's your name?
I'm Eric.
Eric. Then what can we conclude? Caitlin is shorter than Eric. So those are three examples of relationships that exhibit transitivity. Can anybody think of a relationship that is not transitive?
Everything's like the same.
When everything is the same?
Value the same way. And if it's just nothing, there's variables, just wait on the same thing.
Mm-hmm. Give me a little more concrete example.
Okay.
Like what? What's the transitive part? So transitivity means if this and this, then this, right? Is how we put the transitive property in those other three relationships. So I wanna come up with an if this and this, then the then part isn't necessarily true, right? That you can't draw the same conclusion that we could in the others. Right, yeah. So I want you to, so if A equals B and B equals C, then the conclusion we can draw is that A equals C, right? I want you to come up with a different relationship besides equals where I can't conclude this A equals C part, right? I want to have a not equals. There's a good one. If A does not equal B and B is not equal to C, okay, then it's not necessarily true. You can't necessarily conclude that A and C aren't the same number. A could be C. Yeah, so if A was 2 and B is 3, right? Then C could be 2 and A and C would actually be equal and not unequal. So then we can't conclude that A is unequal to C. How about friendship? Is friendship transitive? If I'm friends with Hannah, and Hannah is friends with Kyle, does that mean that me and Kyle are automatically friends? Nope. So friendship is not transitive. Inequality is not transitive. Okay, so hopefully we have a little bit of a grasp of what transitive means. Going back to our preference ballot, when somebody casts a preference ballot, their votes are transitive. That means that we know if the voter likes, so likes is the relationship here, A more than C, well, sorry, A more than B, and B more than C, then what do we conclude? They like A more than C. Then the voter likes A more than C. Because of this transitive property of preference ballot, we can preserve relative preferences even if a candidate is eliminated, right? So let's say you voted C, A, B on your preference ballot. And I go to Netflix and it turns out they don't have Crash, right? So it's no longer a option. I would still prefer A over B. A is not available. So if I can tell as the counter of the votes that this person would prefer C over B, right? Even though A is gone. I don't have to re-vote. I can tell what someone would like when you can compare any two choices. All right, so let's gather all our voting information into a nice, handy little table. Okay, so there's only so many ways we can vote. Okay, so if you have A in first place, then you could either have B and then C as your second and third place choice, or C and then B. Those are the only ways that you can vote for A in first place. Now, if you want to put B in first place, there are only two ways that you can finish filling out your ballot. You could have AC or CA. And if you have C in first place, there's only two ways to finish filling out your ballot, AB or BA. So those are all the possible ways you could vote. There's only 6 ways when you have 3 choices. So now I'm going to count up all the different, how many people voted each of these ways. And I'm going to put the number up top here. So raise your hand if you voted A, B, C. 1, 2, 3, 4. Okay, so up top here we put a 4. There are 4 ballots that look like A, B, C. Sorry, I just got to remind myself how I voted. B, A, C, okay. All right, how many people voted A, C, B? 1, 2, 3, 4. Okay. How about BAC? 1, 2, 3, and was that mine? Okay, 4. How many BCAs? 1, 2, 3, 4, 5, 6. Okay. How many people voted CAB? 1, 2, 3, 4. And how many people voted CBA? 1, 2. Okay, great. So before we decide who won the election, without counting the number of people in the room, how many people voted? How do you know that? Just count all the numbers. So when you're given a preference schedule, you can figure out how many people voted by adding up the numbers across the top. Because these numbers represent numbers of ballots, right? So we have 4, 8, 12, 18, 22, 24. All right. Now, who do you think should win this election?
Yeah, PCA.
Well, we're just picking one movie. We're just going to pick a movie.
Okay, well,
B?
10 votes.
B got 10 first place votes. Yep. A got 8 and C got 6 first place votes. So if we're just going to count first place votes, B should win, right? Okay. So that's a reasonable way to decide. Can anybody make an argument for another movie? That B should not be the winner, it should be somebody else. Yeah.
People who voted against
Mm-hmm. Okay, I see. So you're saying, well, some of these people who didn't vote for B actually have B in last place, right? So maybe people's last place votes should come into account so that we don't play a movie that somebody really doesn't want to see.
That's what we should assign.
Ah, points. Yeah. Yeah, we might get a compromise candidate by using points, right? If there was someone who had a lot of second place votes. Yeah. That can give a good compromise candidate. Yeah. So it's not the most straightforward question, who should win this. So we'll leave it for now. The first method we're going to study in class is called the plurality method. It's the most common, best known method for determining the winner of an election, a natural extension of the democratic principle of majority rule, which states that in an election between two candidates, the candidate with the majority is the winner. So the plurality method is an extension of that says in an election with two or more candidates, the candidate with the most first place votes, who we call the plurality candidate, is the winner. So whoever gets the most first place votes wins. This is the sort of the easiest, most straightforward way to determine a winner. So if you have an election with only two candidates, what can you say about the plurality candidate, the candidate that gets the most votes?
Popular consensus.
Yes. And what do you mean by popular consensus? They would also have a majority. Yeah. So if there's only two candidates and one of them has the most votes, they also have more than half of the votes. Okay. So plurality candidate is automatically the majority candidate. Okay. So in an election that has only two candidates, whoever gets the most votes also gets a majority of the votes. That's not necessarily true when you go above two candidates, right? You can get the most votes and not have more than half the votes. So using the plurality method in our election here, who should win? B. Yeah, B has the most first place votes with 10. Okay. B wins with 10 first place votes. And remind me again how many people voted? 24 people voted. So does B have a majority? No. How many would it take for a majority? 13. More than half would be 13. 10 first place votes. So I'm just going to put note B does not have a majority. So if 24 people voted, half would be 12. A majority is more than half, so you go 1 over 13. So what do you like about the plurality method? What's good about it? Simple, yeah. And that is really important, right? If you're going to be running an election and you want the people to have faith in the results, they need to be able to understand the method, right? So everyone has to understand how this works, or else they could revolt, right? So simple is really important. What else do you like about it? Not necessarily, right? Like, yeah, like in this example, we had B1 with 10 out of 24 votes, which is not a majority, right? So actually the majority of people voted for somebody else. So the majority is going to be unhappy, right? So that actually could be a disadvantage, right? So you can win with less than a majority. In fact, yeah, go ahead. Yes, yeah, true. And the more options you have, the worse this gets, right? If you have 100 choices, someone could win with 1% of the vote. 99% of the people voted for something else, right? So the more choices, the lower the percentage it takes to win. I'm sorry, the more choices. More choices, the smaller percentage necessary to win. All right, so for an election to be considered fair, it has to meet certain criteria. There are certain rules that we don't want to violate. Otherwise, we call the election unfair, right? The first and most basic expectation of any election is if a candidate gets a majority, if a candidate gets a majority of the votes, then they should win. They should be the winner. So if you get more than half the votes, you should be the winner. Does the plurality method always satisfy the majority criterion? Why not?
Last election, won by winner take all.
Correct. Yes. In our presidential election system using the Electoral College, it is possible to get a majority of the votes, a majority of the popular vote, and lose the election, right? But that is a different system than the plurality method that we just learned. Okay? If we were using the plurality method where one voter, one vote, and not a winner take all in the states, would it be possible to get a majority of the votes and lose? We're just counting first place votes.
First place.
Yeah.
That is possible.
Yeah, you can have more than half the votes and lose.
I think so.
Let's examine. Let's say there are 3 candidates.
Yeah. Most will that's
Mm-hmm.
that's like 18% of the possible, 13% of the popular vote.
Right.
Yeah, I can see that.
Yeah. So say we have 3 candidates and 100 votes. We'll have candidate A, B, and C. Now the rule says that if someone gets a majority, they have to win, right? So let's give someone a majority. Let's give candidate B, how many votes should we give them? 51 would be a majority. Now how many votes are remaining to give out between candidates A and candidate C? 49. Is there any way anyone other than candidate B could win? Nope, not in just a straight up counting first place votes, which is what the plurality method is. A and C have to now split 49 votes. Even if one of them takes all the remaining votes, there's no way they can beat B. So in the plurality method, if someone gets a majority, they will always win. Okay. If you get a majority, you will win. So the plurality method will always satisfy this criterion. If someone gets a majority, correct, that's a good point. In our case, no one got a majority. Does that violate this rule? If no one got a majority, what does this rule say about no one getting a majority? It doesn't say anything, right? It doesn't say they can't win. It doesn't say they should win. So this is something really tricky about if-then statements. When we use them in a math class, they are very specific. The only way to break a rule that's stated in an if-then format is if you satisfy the if part and break the then part. Okay, so here's an example, real life non-mathematical example. Let's say that I have created a rule for myself that if the temperature is over 30 degrees, I will go outside for a run before I go to school. Okay. If the temperature is over 30 degrees, I must go outside and run. So let's go through a few different scenarios, and each time you tell me if I broke the rule. The temperature is over 30 degrees and I went outside for a run. Did I break the rule? No. Perfect. Okay. The temperature is below 30 degrees and I did not go outside for a run. Did I break the rule? Okay. The temperature is below 30 degrees and I still went outside for a run. Did I break the rule? No, I did not. The only way to break the rule is if you satisfy the if part and break the then part. So here's the last one. The temperature is above 30 degrees and I did not go run. That's when I broke the rule.
Change things in the greater sign. It's supposed to be greater than 30.
Yeah.
And if that remains 0, then you broke the rule.
Correct. Yeah. So the only way to break this rule is if somebody has somebody has to get a majority and lose. That's the only way to break this rule. So I should write that down. The only way to break the majority criterion is if someone gets a majority but loses. Now that might sound crazy. How could somebody get a majority and lose, right? It's impossible with the plurality method. But as some people pointed out, the method that we use to elect candidates in our country with the Electoral College, it is possible to get a majority of the votes and lose. Okay, so it is possible to violate the most basic fairness criterion of an election. If somebody has a majority of the votes and loses, we say that that election violated or failed the majority criterion. We broke the rule.
Generally doesn't matter at all.
Right, if you're just counting votes, it's hard to break this rule. Yeah. You have to be doing a little bit more of a complicated calculation, like the Electoral College, yeah, and like some other methods that we're going to learn in this chapter, but not the plurality method. When you're just counting first place votes, you can't break this. All right, so we got another one. Here's a second fairness criterion. This one says that if you have a candidate, candidate X, we're going to say if they're preferred by the voters over every other candidate when you match them up head to head, then candidate X should be the winner. So this is like sounds a little bit like, what does that mean? So we're going to do an example to show you what it means to be a Condorcet candidate. So here's an example. We have Tasmania State University. They have been invited, the marching band has been invited to 5 different bowl games to perform. They can choose from the Rose Bowl, the Hula Bowl, the Fiesta Bowl, the Orange Bowl, and the Sugar Bowl. And here are the results of the vote in a preference schedule. Okay. So using the plurality method, which just counts first place votes, which bowl game are they going to? The Rose Bowl. The Rose Bowl has 49 votes. The Hula Bowl has 48. Sorry. Rose Bowl 49. Hula Bowl 48. And the Fiesta Bowl has 3 votes, 3 first place votes. So we're going to the Rose Bowl. Now, look at the other 51 people who voted, these 48 and these 3. Where did they rank the Rose Bowl? Last, right? They do not want to go to the Rose Bowl. So it might be that the Rose Bowl is not the fairest choice in this instance. So what would be, what do you think would be a good compromise choice looking at this preference schedule? H, yeah, because these 49, they'd be okay with Hula. It's their second choice. And these 48 obviously would be okay with Hula because that's who they voted for. And these 3, Hula is their second choice. So this might be a really good compromise candidate. Let's look at Hula. I'm going to compare Hula to the Rose Bowl, Hula to the Fiesta Bowl, Hula to the Orange Bowl, and Hula to the Sugar Bowl. I'm going to match head to head Hula against everybody else and see who wins. When I do Hula against the Rose Bowl, I'm going to go back and look at my preference schedule, and I'm going to look at each column and decide, based on transitivity, who they would have voted for. So these 49 people, if they have to choose between the Rose Bowl and the Hula Bowl, who would they pick? Rose Bowl, because they have it ranked higher. Okay, so we have 49 people for the Rose Bowl. Now these 48 people, if they had to choose between Hula and Rose, who would they pick? Hula, because it's ranked above Rose. So we're going to give these 48 votes to the Hula Bowl. And then those last 3, they have to choose between Hula and Rose Bowl. Who do you think they would pick? Hula Bowl, because they have it ranked higher. So those 3 go to Hula. So Hula gets 41, Rose Bowl gets 49. Hula wins that head-to-head matchup. All right, so let's do a head-to-head matchup, Hula versus Fiesta. So these 49 people, if they have to choose between Hula and Fiesta, who do they pick? Hula, ranked above Fiesta, so they choose Hula. So we give 49 to Hula. These next 48, do they choose Hula or Fiesta? Hula. And these 3, Hula or Fiesta? Fiesta, because they have it first. So 48 more go to Hula and 3 go to Fiesta. 48, 3. So this one ends up 97 to 3, Hula to Fiesta. All right, let's see. Hula versus the Orange Bowl. 49, who would these people pick? Hula or Orange? Hula. These people? Hula. These people? Hula. Everybody picks the Hula Bowl in this case. So we have 100 to 0. Hula wins. Hula versus Sugar Bowl. Hula. 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 100 to 0 again. Hula wins. So if you ask anyone in the band, right? If you conduct a vote where you ask the band to choose between Hula and any other bowl, they choose Hula. So we call Hula a Condorcet candidate. They are preferred by the voters over every other candidate in a head-to-head matchup. So Hula is a Condorcet candidate. Right? Yet, when we decided this election using the plurality method, who won? The Rose Bowl, right? So Hula is a Condorcet candidate, but the Rose Bowl won. That means we violated the Condorcet criterion. If you have a Condorcet candidate who loses, you violated the criterion. Okay. So this election, using plurality method, violates the Condorcet criterion. Because a Condorcet candidate lost. You have a Condorcet candidate, the criterion says that candidate should win. If that candidate loses, you violate the criterion.
Try to clarify, use plurality. Plurality said the Rose Bowl wins, yet the Condorcet candidate wins. That's a violation of the rule completely.
Right. Yeah, we have a Condorcet candidate. The criterion says that that candidate should always win. If there is one, they should win. Yet, when we use plurality, a different candidate won. So we violated the criterion. And Condorcet, by the way, is just a French name, the person who came up with this concept, if you were curious where that came from.
Now, is that because of the way that you formulated this table of information yourself?
Yes, yes, I rigged it. Yes, I rigged it. The Condorcet criterion gets violated most frequently in controversial elections, when you have a lot of people who have a candidate first and a lot of people who have that candidate in last. So you have a really polarizing election. That's when the Condorcet criterion can be violated, sometimes be violated. Right, so it doesn't happen every time, only in certain circumstances. But it's still a bad thing to have happen. So I'm going to go back to our advantages and disadvantages table. And one advantage of the plurality method, well, I'll do the disadvantage first. Sometimes violates the Condorcet criterion. Can sometimes violate the Condorcet criterion. But a good thing about it was that we always satisfy the majority criterion. It's impossible to violate the majority criterion with this method. Yeah, the majority candidate will always win. But the Condorcet candidate doesn't always win. Sometimes they can lose. Well, there is no, we don't get to have an opinion about who we want to win. The method just determines who wins. So we were using the plurality method, which means R1. Okay, the Rose Bowl won. But then we can have opinion about whether or not that's fair. Yes. Yeah, in fact, that's a disadvantage of the plurality method, is that it does not take into account anything other than first place votes. It throws away a lot of information. Yep. So it only considers first place. First choice. So there's a disadvantage. It's ignoring a whole lot of information. You don't even need to collect it. All right.
As we saw that breakdown occur when the plurality is more choices you have.
Yes.
Needed to win, 48% won. It was a minority vote, basically, and still won.
Yep. You got it. Yep. Yep. So we have one more major flaw of the plurality method, and that is the ease with which the results can be manipulated by a voter or a block of voters through something called insincere voting. In insincere voting, if we know the candidate that we really want has no chance of winning, rather than vote for that person and waste our vote, right, because we know they can't win, we might vote for a candidate, we might switch and put our second choice candidate in first place, right, to make sure that the person we hate doesn't win, right? So for example, in the marching band election, these three members on the end, they really want to go to the Fiesta Bowl. That's their first choice, right? But let's say they've heard the talk, they know nobody else but them are interested in going to the Fiesta Bowl. So how could they change their votes to create an outcome that they would like better than the Rose Bowl winning? Because right now the Rose Bowl is going to win. They really don't want the Rose Bowl to win because they have them in last place. What could they do to manipulate the outcome of this election? They vote for the second best. They could switch these two. Now Hula Bowl wins. They've completely manipulated the outcome of the election by not putting their true first choice first. Where have you personally seen this before? Yeah. Yes. Yep. Nader was the wasted vote, the spoiler. Yeah. Yeah, and Ross Perot. Third-party candidates in general have a really hard time gaining traction because people feel like they're wasting their vote.
Same with Jill. Right? Jill,
yes. Yeah. Mm-hmm. The two, they're, yes, because of all the problems that arise when you add a third candidate, we, yeah, this is a consequence of insincere voting in the American system, is that it's really hard for a third-party candidate to get any support because people think that they're going to be wasting their vote. Okay. That's a good question. That might help.
What was established in politics at that level, it has already been plugged in for, let's say, 100 years.
Yeah.
No, they totally blew on no new person can gain access without tons of money too.
Yes.
So what do we do?
Yeah, so changing our method of voting might help, and as we study more methods, you might discover one that you think would be better. Yeah. So we have this entrenched two-party system because people are afraid of wasting their vote. So that about finishes up our first lecture. This is just a little list that will be at the end of each of your lectures, so you can go like, oh yeah, I know how to do that, I know what that is, just to, after you've done your homework, to make sure that you're on top of things. Your homework is in my math lab. It is due Wednesday of next week. There's also a little intro to my math lab assignment that's due Wednesday also.